Gang. I'm one of your hosts, Jonathan Ullman, alongside Gucci Gang, 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 Tom K.
What's up, everybody? How we doing?
Good, man. How are you?
Doing all right.
Weren't expecting that one.
Nope. I'm not sure what that's even in reference to.
You're not privy to the Gucci Gang, huh?
No.
Okay.
Sorry about that.
You don't live here, then. that much I can tell you. Kyle, you know what that was in reference to.
All right.
Yep. We'll throw it on. Maybe if we really want a copyright strike, we'll throw that on as the outro music in stark contrast to the elevator music for the intro there.
Sounds good.
It's a good song.
Cool.
Yeah. How are you?
Doing good. Ready for the show as usual?
Yes. I really didn't even have to ask because we've actually spent the whole day together.
Yeah.
So I know that you're
doing well.
You're doing good.
You took good care of me today, John.
I tried to. I always try to.
So what do we do here?
What do we do here? Tom, you and I, we get together on Monday nights and we talk about all of the trending science news topics from the week prior. That is what this show is. That is trèSci Weekly. And, oh, you over there. Thank you for joining us on this fine evening. Yeah, you can always check this show out on Monday nights. Join us for the live viewing of it, the live recording of it, of course.
On YouTube.
On
we
our
have
YouTube
the live
channel.
chat if you would like to tell us how great we are or how we could improve.
Yeah. And, if you just want to jump in and chime in on some of the stuff that we're talking about.
That'd be great.
That would be awesome. Of course, if you're watching this on the replay, that's fine too. We understand that not everybody's Monday night is free. So if you're catching this on the replay, we appreciate it. Of course, consider subscribing to the YouTube channel and thumbing up the video if you like what you see here.
That always helps.
Definitely always helps grow the stream here. We also have some other outlets for you to check out. We've got our Facebook page, we've got our Twitter page, and our Instagram page all up and running, firing away on all cylinders, as they say. And if you'd like to financially support us, you can always go over to patreon.com/trèSci Weekly. Throw us a couple bucks. Of course, that helps grow everything, not just the stream, but the library programs that we do as well. So
just trèSci in general.
Yep. So yes, thank you for being here. And without further ado, Tom, I think we should get on in. Begin the show with what is and forever shall be the lightning round.
Yes.
Are you ready?
I am ready.
All right. So, number 1.
Here we go.
Popsci tweeting, Neolithic women were probably a lot stronger than you.
Than you in general. I lift weights, Popsci.
Yeah, maybe not you, but
the general you.
Yeah, the general. Maybe us.
So what are we saying? Neolithic women were stronger. Why?
So that's a great question. We're talking about prehistoric women from around 7,400 to 7,000 years ago. The study was conducted comparing now prehistoric women to modern day women that are collegiate athletes, most prominently rowers. That's why there's an image of the row team over there.
So they're basically trying to say, how does the Neolithic women's strength stack up to athletes of today?
Correct. Because prior comparisons had been made to Neolithic men, right?
At the same time.
Same time frame. And so there hasn't been a real true sort of sense of what the strength of these women in the prehistoric times really
relative
was.
To today. Yeah.
Right, especially, relative to today. So the study that they report on finds that compared to the rowing team at Cambridge, arm strength was 11 to 16% stronger, whereas leg strength was pretty much on par. And they attribute that to repetitive tasks such as grain grinding, back when kind of farming really took hold.
So they just have to be grinding grains all day, and that's what made them stronger, huh?
Yeah.
So how did they do this? They were looking at bones?
Yes, they were looking at the remains, I guess, of some known samples of Neolithic.
And you can sort of extrapolate from bone to muscle, kind of?
Yeah, so the way that muscle presses up against a bone can really shape it. especially if it is
sort
a repetitive
of giving
task.
you like the force that goes into it.
Yeah, correct. But yeah, there was a lot of discrepancy I guess, between how a male and female bone develops, especially in response to strengthening.
Mm-hmm.
So, yeah, it was, this is kind of a first study that really looks at it from that perspective instead of just trying to lump it all into a time period, really looking at it from
Compare the then and now,
yeah, from more of a gender point of view.
So, I mean, makes sense, right? They had to farm a lot, do a lot of work. They were probably pretty strong.
Yeah. Stronger than me, you think?
Maybe.
Probably.
All right. Cool. Number 2. This one's coming to you from PopSci. Yetis Are Bears. Confirmed. So this study was looking at a lot of the reports. People were trying to say that there's evidence of a Yeti. Turns out most of the time it is, in fact, just a bear. So what we looked at, 9 samples of supposed Yeti artifacts, and then 15 from known bear species. And they looked at the mitochondrial DNA sequence that was in there.
The mitochondria is the powerhouse of the cell.
Exactly. That's what everybody knows.
Yeah.
But you can actually look at the mitochondria to just learn more about what you're looking at. It's like a good indicator of it'll tell you where it came from, kind of thing.
Yeah.
So when they looked at all these samples, all but one of the Yeti artifacts were tracked down to a local bear. So was there one Yeti?
I guess so.
Nah, the last one was a dog. So they were all bears and a dog. Turns out nobody found a Yeti. Go figure.
Yeah.
But
big shocker.
What's interesting is that the Himalayan bears that they're looking at, they're genetically diverse from other brown bears. So I guess you could call them a Yeti as like a nickname for them. They live on the top of the mountains. They're kind of in their own place. So they're the Yeti of the bears.
I get you. What would you do if you ran into a bear while climbing the Himalayas?
What are you supposed to do with bears? You're supposed to be strong, right? Or first you're supposed to see what happens, and then you're supposed to be like, "Yo, I'm tough, bear. Back up."
You make yourself bigger, and you try to scare the bear off.
You're not supposed to play dead, right? I don't think so.
No, I don't think so. Maybe if it's gonna
maul you, then you
play dead.
Yeah,
you don't run away.
Yeah, you don't just run away.
Sure, you're not supposed to do. I mean, if you're on the Himalayan mountains, you can't really run away anyway. Where are you gonna go?
Very true. So it turns out, all the Yetis are bears.
All right,
go figure.
Yeah, excellent. Glad science cleared that. Yeah. Next story, number 3. This one comes by way of sciencenews.org. They write that there is a jackpot of fossilized pterosaur eggs unearthed in China.
Ooh, pterosaur with a P, right?
Pterosaur with a P. Yeah, that's a tough one there. So those are the kind of flying dinosaurs, the winged ones.
If you saw Jurassic Park 3, it's the one that steals the mom's kid.
Yes.
It just grabs him and flies away with him.
I have a distinct memory of when, in that movie, when the little boy is crossing the bridge.
Yeah, exactly. And then the pterosaur swoops in.
Yeah, and it's all foggy, and then he's like, "Mom?" And then pterodactyl goes, yeah. Oh man, it's a bad movie.
I'm glad you got that reference.
Yeah. Somebody had to. So they found a treasure trove there of 215 pterosaur eggs in the Turpan-Hami Basin of northwestern China.
That's a lot.
That is a lot.
That's pretty impressive.
Like unfathomable for a dinosaur
from a
remain.
research standpoint.
Mm-hmm.
Yeah.
And so what they were able to do is look at 16 of those fossilized eggs had embryos that were able to reveal some of the details of how those particular dinosaurs, grow and develop within the egg before they hatch.
Because if you're a fossilized embryo, that means you're at the part of becoming an egg to become a dinosaur. So you get snapshots of development.
Exactly. And they were, I guess, at separate timestamps of their development.
They sort of extrapolate
while they were fossilized. So what they noticed was that the leg bones developed before the wing bones in a lot of cases. And that could potentially indicate, Tom, that these pterosaurs are able to walk before they are able to fly.
Kind of regular birds can pretty much hop around before they're soaring out of the nest, right?
That's true, yeah.
Same sort of thing.
But that's a little bit of an extrapolation.
That's
because,
not for sure, yeah.
Yeah, because some of the scientists looking at this are saying, well, there's still a long probably a long period of time before the egg actually hatches. So that's not to say
they don't know the exact age of the embryo to make that exact claim.
So the wings could develop in that time frame. Not really too sure yet. The other thing that they pointed out was that there were large groups of these eggs, so it could potentially mean that the pterosaurs had colonies that would lay eggs together. But again, the fact that they found them all together in this basin, preserved in such a way, means that there was likely some catastrophic natural event like a flood or a storm
that sort of just swept everything up, put it all together.
Exactly.
And that's why you find them all in the one spot.
Right. So, there is some speculation to the findings here, but, maybe a little bit over speculation. But with this amount of data, I'm sure something, more concrete will come out of this.
As time goes on, that's a lot of eggs to be studying and to just find out of nowhere.
Yeah.
Pretty cool.
Definitely.
Moving on. So the next one, number 4, this one's pretty interesting. So this one's coming to us from
Science Magazine.
Yes. So this one is, the title says that microbes engineered to host 2 additional genetic bases could produce over 150 different amino acids. So first, let's just break it down real quick. When we're talking about genetic bases, they're A, T, G, and C.
Mm-hmm.
Those are the 4 bases that come together to make all of your genes in your body. Just those 4 letters.
Yep.
So what these scientists did is they introduced synthetic bases that they made. They call them X and Y, not to be confused with your chromosomes. Just what they call them as a type of bases. And by adding these new synthetic bases to your 4 bases, what they were actually able to do was to take the 20 amino acids that you can usually make out of the A, T, G, and C, and then using these new synthetic bases, got over 150 amino acids from the normal 20. So it's hard to say what that exactly means, right? But 150 amino acids is way more than 20.
Yeah.
So there's got to be some sort of application into pharmaceuticals or medicine, or who really knows, right?
Yeah. So I guess these synthetic amino acids, we don't even know what their properties are, right? Like, whereas we can say, okay, in a given set of DNA, you have, A, T, G, G, C, T, A, like whatever the strand kind of reveals itself to be, and that codes for production of hemoglobin. Like maybe that's just what that does, and then we know what hemoglobin does as it relates to our bodies. But if we add in these synthetic bases, these X and Ys, that just
throws everything off.
Yeah, that throws everything off. That makes for a vast amount of potential differences. And so now, these biologists are going to look at this and have to test out one by one, like what do each of these
do?
Each of these different amino acids do.
Because in every organism, it's 20 amino acids, right?
Yeah.
That's the building blocks of all the life on Earth.
Yeah.
So going from 20 to 150, I mean, this could be really amazing as we follow this story about what actually comes out of this one.
Yeah. So a lot of people were referring to it as alien DNA because, it's not natural to life here on Earth. I tweeted out, Tom, from our account that if aliens were to come to the Earth and study genetics, study human or life here as genetics sort of provide. If we now introduce synthetic pieces to our DNA, they're gonna have a real heck of a time trying to wrap their brains around that and figure
what
out
are these guys?
Yeah, how did that happen? Where did this come from?
So yeah, pretty cool stuff. Synthetic nucleotide bases.
Yeah, absolutely. Moving on, what are we on? Number 5. We've got from, again, Science Magazine. Nations agreed to ban fishing in Arctic Ocean for at least 16 years. This is more of a policy story than a research story, but basically, Tom, 9 nations and the European Union, so actually Canada, Denmark, Norway, Russia, the United States, Japan, China, South Korea, Iceland, and the EU as an entire entity of itself, came together and they signed an agreement that basically prevents commercial fishing in
the Arctic Ocean.
Yeah, in the central Arctic Ocean, which is really just opening up because of sea ice extent. Yeah, is not reaching as far down as it used to.
So it's just more waters open to fishing.
Right.
So then you got to regulate it.
So yeah, so now all these boats can now freely travel into this area, and fishing boats, I'm sure, would be interested in this prospective location because
they're saying
no competition there.
Just opened up, the ice just melted. Like, let us take stock of all the stuff, and then maybe you can fish it all.
Yeah, maybe. Yeah. So I mean, it's kind of a nice way of going about it. Nobody's saying that like we can never fish there. But like, let's take 16 years. Let's.
How do you think they came up with 16 years?
That's a good question.
Kind of a weird number, but
definitely.
It's a good portion of time.
Yeah, I mean, for our politics, like, things sort of turn over every 4 years. So 16 by 4. You figure,
you
get
least common
denominator. I don't know. But yeah, so I think the main reason why they're doing this, and what the article goes on to say, is this has happened in the past. In the 1990s, there was a population crash of pollock fish species where they fished it to death basically, and it still hasn't recovered fully. So they don't want the ecosystems that might be fragile in the Arctic to basically
just have this intense
completely
fishing,
completely interrupted there. So I thought that was a nice policy story, Tom. Sometimes we talk about policy stories and
they're not so nice.
Yeah, and they're heartbreaking. So
very true. All right, moving on to the next one. We're talking about bats and SARS.
Bats and SARS.
Oof, scary stuff.
Yeah.
So SARS, just so we're all aware of, stands for Severe Acute Respiratory Syndrome. We all know SARS is a bad thing when you hear about it. That's what it exactly means. And there was an outbreak in 2003 that passed the virus from cats living in the markets to humans. That's like sort of where it came from. But why are we talking about bats? The reason is that the bats sort of have the virus within them that's sort of dormant and doesn't affect the bat itself. But these are where we're looking for strains of SARS where they might come from for the future. So we need to be aware of what's going on in the bats and sort of how SARS might reemerge from the bats themselves.
Okay. So SARS could still potentially be some kind of a threat then.
Yes, because of the SARS as it lives inside the bats. But a good point that they make up is that the bats don't get sick from the SARS, so we can look to see how the bats are made up of and what makes them impervious to these strains of SARS. So it might be a risk to us, but it also might show us the way to combat it if it becomes a problem.
Gotcha. Kind of like studying snake venom, right?
That's true too.
Snake venom, the poison is usually, that's how we make the toxin.
It's deadly.
Yeah, that's how we make the toxin for it, right? Or the antidote.
The antidote.
Yeah. Not the toxin. What am I talking about?
Yeah, it's usually the animal that has the poison has the antidote for it too,
right?
Because it doesn't kill itself.
Yeah,
exactly.
SARS outbreak was in 2003. Do you believe that?
It seems more recent than that,
right?
To be honest,
14 years ago? My goodness. Kyle, how old were you 14 years ago?
6.
6? 7? Okay.
He's up there.
He's getting up there. Next story. This is a fun one, Tom. Elon Musk took to Twitter. Elon, of course, being the esteemed SpaceX / Tesla / PayPal / anything, pretty much everything that everybody talks about nowadays. Leader.
He's got a good social media presence too.
Yeah, he's got a good thing going for himself. He took to Twitter and he announced that the Falcon Heavy, one of SpaceX's proprietary rocket technologies, is going to take off, is going to launch next month. And he followed that tweet up by saying, quote, "Payload will be my midnight cherry Tesla Roadster playing Space Oddity. Destination is Mars orbit. Will be in deep space for 1 billion years or so if it doesn't blow up on ascent."
So by payload, he means the car is going to be the thing that's inside the rocket that they're sending all the way up there.
Right.
And then eventually the car will end up in orbit.
Yeah. So, Sci-Fi's Phil Plait,
who's also an astronomer.
reached out because Elon Musk tweets a lot of crazy stuff sometimes.
Like, how do you know if he's joking or not?
Yeah.
Like, is he just trying to get publicity for Tesla? Like, what's the deal with this? Yeah.
Right. So, nobody was really sure if he was kidding or not.
Yeah,
and
they had to ask him, right?
So Phil Plait reached out and said, "Are you serious? Like, are you really gonna launch your car like into orbit?" And he is. He is serious about doing that. It's his own personal Tesla. It is somewhat of a publicity stunt in order to showcase,
for the whole thing,
how powerful the Falcon Heavy, how much thrust they can.
That they could just send a car up there.
Yeah. But kind of the caveat here is, as he says, destination is Mars orbit. He's not sending his car to Mars, right? Okay. Not even to a Martian orbit where it would orbit around Mars. The payload is actually going to orbit the sun in an orbit that would take it as far as Mars in its own orbit, and it would teeter between Earth and Mars
as it orbits the sun.
Exactly.
Okay. So we'll have a Tesla just orbiting around in space.
Yes.
Right on.
If it doesn't blow up on ascent.
That's true.
Which he's pretty frank about.
Because this is a pretty giant rocket they're testing out, right? The Falcon Heavy. This is a massive launch that's going to be taking place.
Yeah,
right?
I believe this is going to be the first launch of Falcon Heavy. I'm pretty sure.
So it would be pretty remarkable to have a successful launch. First try?
Yeah.
So we'll see it. Yeah, it might very well blow up.
Yeah.
A lot of SpaceX's very early launches ended up in explosions.
Yeah.
So we'll see.
It'll be exciting.
At least his car will be in there. You could watch it.
Yeah.
All right. Next story. Moving on from that one. So we're talking about the NASA moon. If you were on Twitter, Facebook, anywhere, everybody was talking about a supermoon.
Mm-hmm.
So how super is a supermoon?
Yeah, what is that? What even is a supermoon, Tom?
So
clear that up for me.
A supermoon, just the definition of it is when you have the full moon, you can see the full moon in the sky, and it happens to be throughout its orbit at its closest approach to Earth while it's a full moon.
Okay.
So it's like the nicest look you're going to get at the moon.
Okay.
But to call it a supermoon, do you think it's justified? So how much bigger is it actually than the normal moon? So we have that it's 14% larger and up to 30% brighter. So kind of a decent amount.
It's worth noting, I guess.
If you're outside and happen to look at it, it's like, oh, there you go.
Yeah.
But it's not that crazy impressive. I saw a funny tweet from Neil deGrasse Tyson saying that if you had a 16-inch large pizza, that the super moon would be a 16.1-inch pizza.
So a super pizza.
A super pizza to a pizza.
Right.
Exactly. It would only be 0.1 more inches in circumference.
I mean, that's still better.
You'll take the 0.1 inch of a pizza. But
yeah,
it's not like anything super.
Yeah. I think Nintendo really screwed this all up for us because they went from the Nintendo Entertainment System, the NES, to the Super Nintendo Entertainment System.
And now everyone just wants to call everything super.
Yeah,
You're blaming it on them.
Yes, I am. I am. It's entirely their fault.
But yeah, nothing too crazy about the moon.
No.
Looks like it usually does.
What's somewhat interesting, though, is this will be the first of 3 consecutive supermoons. So I know it was cloudy last night, so around here...
Couldn't really see it all good.
Yeah, nobody could really check out the supermoon. But you'll get another opportunity on New Year's Day. It will be the next full moon, next supermoon. And then the third one in that consecutive kind of thing of 3 there would actually be on January 31st. So it will be a super blue moon.
Oh, wow.
Because a blue moon is when you get 2 full moons within the same month. Yeah. So
I'm sure we'll see that all over Twitter. The super blue moon.
Yeah. And we'll have to explain what that means because, that's going to be very misleading. All right. Tom, I see your NASA moon tweet. And I raise you a NASA Voyager 1 tweet.
This one's pretty cool.
Yeah. So NASA's got this spacecraft called Voyager 1 that they launched a long time ago, almost 40 years ago.
Yeah, pretty amazing.
And the goal was to send it out of
our solar system.
Out of our solar system into interstellar space.
And beyond, right?
And beyond.
Just keep going.
As far as you can go. yeah, there's some really interesting kind of conjecture about Voyager 1 and Voyager 2, which were both launched, relatively similar times. But what they had to do here, Tom, is they had to turn its thrusters back on to sort of reorient the position that it was moving. Yeah. And they haven't done that in 37 years. So it's almost, a miracle that these thrusters turned back on at all.
So they were able to turn back on.
They did it, yeah. Currently,
so how far away is it? Yeah.
Currently, Voyager 1 is 13 billion, billion with a B. 13 billion miles from Earth, Tom. That's approximately 140 times the average distance between the Earth and the Sun. So
it's out there, yeah.
It's out there, yeah. Pretty freaking far.
13 billion miles.
Yeah. So it took them 19 hours and 35 minutes of travel time just from the information to
reach Voyager.
Right, to transmit from...
Because that's traveling at the speed of light, the transmission.
Yep. The radio transmission
So it took almost 20 hours.
Yeah.
And then what kind of thrust are we talking about? We're not talking about, like, firing on afterburners.
No.
Because this is,
not a lot of fuel left. They had to use a lot of fuel just to get it out of Earth's orbit, and then, around Jupiter, they speed it up, and they do all these crazy, accelerations. So 10 millisecond thrust pulses. No need for anything more.
So just like little shoots of to like reorient it. Yeah.
When you're out that far,
but it still worked.
Yeah. And when you're out that far, there's not a lot of gravity tugging on you at all. So just a short little readjustment, and you're off on your way.
Gliding away
like this, like a dove.
So as we were talking about it, 37 years if you left something in your garage on Earth. I mean, that's probably not firing up, right?
We've got a dishwasher that we left in the garage for like one winter, and I guarantee you it's busted. Yeah.
So, but the conditions of space aren't really inviting, right?
No.
So it's out in almost the vacuum of space, almost nothing there for many, many years.
It's about, a handful of degrees above absolute zero, which is
as cold as it gets.
Yeah, it's as cold as it gets. There is no atmosphere out there, so there's no protection from harmful radiation, be it, X-ray radiation from some star cataclysm happening, far off in the distance, or gamma ray bursts that are happening out in space there, These things radiate in all directions, and, Voyager 1 is not protected from any of that, so it's quite amazing that it's
still going.
Yeah, it's survived the trip. I guess it really speaks to how they built it way back in the day.
Yeah, quality engineering.
They don't build them like they used to. Tom. They just don't
That's
build
what
them.
they say.
So Voyager 1, the only human-made spacecraft to reach interstellar space. Voyager 2, however, likely will reach it in the coming years. It's kind of tough to say, right? There's a loosely defined area of where interstellar space begins, where you don't have that totally worked out yet. Where does the sun's influence end? That's kind of what these two spacecraft are.
We're trying to figure out, right?
Looking to find out. Pretty cool.
Sounds good. So moving on from that one, the next one, we're talking about earthquakes again.
Oh boy.
But the last few earthquakes we've talked about were big ones along plate boundaries that were a lot of damage and a lot of just destruction. This one we're talking about was actually just in Delaware. Do you remember which day this was?
This must have been. Let's see. Let me
check it out real quick. Yep. Delaware, the state, not too far from us. So this was on November 30th?
Yes.
Sounds good. So in Delaware, there's no fault lines. So what's going on in Delaware? Right?
You tell me. I have no idea.
So a few stats about it. The largest earthquake that occurred within the 90-mile radius since the 1994, magnitude 4.6 near Pennsylvania.
Okay.
And it may be the largest earthquake in Delaware since 1871.
Wow.
Because Delaware doesn't really get a lot of earthquakes.
No.
So to get a 4.1 in Delaware is kind of a big deal. So the shaking, people reported feeling it from DC to New York. Did you guys feel any shaking?
I did not.
No, right?
No.
My grandma lives in New Jersey. She also said no shaking. But it's actually a measure that they use at USGS a lot. They rely on people to just tell them, did you feel it? To sort of narrow down and figure out what exactly happened.
Yeah, that's an interesting metric.
Right? They always ask you, did you feel the shaking?
Yeah.
And so like we mentioned, there's no plate boundaries, but within the continental plate itself, there just exists a certain amount of stress that eventually needs to get released somewhere. So this time it happened to be in Delaware. And I've recently been reading more articles about fracking and other things that would make that continental crust and land just, a little more fragile and sort of make it a little unstable. And they're saying they're leaning more and more towards that those type of activities can lead to intercontinental earthquakes like this one.
Interesting.
So things we need to monitor and keep track of, for sure.
Yeah, I mean, important to note, there was nothing in the USGS sort of press release about fracking having any influence on this one.
On this
particular,
one, yeah. That's a great point to make. For this one, that's just sort of the way it is.
Yeah.
But I just wanted to mention that I've been reading that they're sort of trying to correlate the two more and more, specifically in Texas is where I've been reading
Texas, Oklahoma. There's been a pretty big spike in those small magnitude earthquakes over there.
As they've been
doesn't
doing
make
more
a lot
and
of
more.
sense. Tom, I don't know what... Sorry.
Go. You go first. You first.
I don't know why this popped into my head, but can you remind me, what is the name of the plate that has sunk into the Earth's upper mantle?
Like underneath North America?
Yeah.
That's the Farallon plate, right?
Farallon plate, yes.
I think that's how you call it.
Yeah, thank you. That word escaped me.
Yeah, so if you think about it, there's literally an entire continental crust that submerged underneath us that's being incorporated into the mantle somehow.
Yeah.
Like recycling a whole part of the Earth.
Crazy.
And then just a quick story about this one. When I remember thinking about shaking, I was actually playing Xbox a few years ago over the headset. One of the guys said, my room is moving or shaking or something. And I was like, this guy is on drugs or what? I don't know what he's talking about. And then I heard that in Virginia that day, that's when there was an earthquake. It was a few years back. And so it turns out that guy actually felt shaking from an earthquake.
I remember that.
Yeah, I thought he was just a crazy person.
Yeah, people around here actually
some people
felt
reported
that as well.
It. Yeah,
I did not. I was actually in Maine at the time.
Oh, okay.
But yeah, I remember that. I remember that happening.
All right, moving on.
Moving on. This one comes by way of NOAA Satellites on Twitter. NOAA's GOES-16 satellite. That's the geostationary orbiting Earth satellite, I guess.
Yep.
That's what that would stand for. 16 is the most current version of that satellite. Geostationary means that it's just following one point on the Earth. So as the Earth kind of turns, it's
always over the same point.
Always over the same location. They're moving GOES-16. They're gonna drift it, as they say, into a new position.
They're gonna drop the clutch.
Yeah,
they're gonna drift it.
Tokyo drift it.
So they need to move it a little bit, right?
Yeah, so they're gonna move it to a new position. It's actually going to take about 11 days to move to the east. So I guess, to the east would be this way. No, the east would be this way if we were in a compass.
Okay, all right. I was like, where are you going?
Yeah, I don't know where we're going with this one. So they're going to move it over to where GOES-13 is currently residing.
And then they're going to move GOES-13, right?
And then they're going to get GOES-13 the heck out of there.
They're sending it up 60 degrees west longitude, so they're moving it out to a different location?
Correct. All the while, Tom, right? Drifting makes this sound as though they don't really have any sort of plan as to how they're going to do this. No, there's a very by the books sort of plan in place here where the instruments have to get shut off or put into safe mode or standby, whatever. They will sort of lower GOES-16 so that it can move kind of
bring it at a lower altitude so it can sort of gain some...
Right. And it can move against the rotation of the Earth a little bit, and then they'll bring it back up in altitude. Yep, so that it reaches that geostationary orbit again.
So it can keep taking pretty pictures, right?
Exactly, yeah. This is all really important to our weather data. National Weather Service uses GOES-16 quite a bit.
Yeah, if you've ever seen like a a long image where they like show the clouds coming out and how they move across the country. You're getting that from a NOAA satellite.
Yeah.
From one of these guys.
And they have all of this in place so that as they're rearranging these satellites, there will not be any loss of data for us to utilize with our weather monitoring stations across the country, which is really important, especially because we've had such an active hurricane season. You never want any second of data to go by the wayside there. Not that we're concerned with hurricanes this time of year, hopefully. But if all goes according to schedule, GOES 16 should come back online by December 20th. And they're already making preparations for GOES 17's launch
in 2018.
Yep.
Sounds good. So moving on to the next story, John, we're talking about corals. Corals.
Oh, corals. Getting the present, coral.
So it's Corals Week, so that's why we're talking about coral. So we have a little video from NOAA. Would you like to check out the coral video with us?
That's true. I don't know. Kyle, did you get that second email with the video?
Getting it right
now. Okay.
Oh, I forgot we did that.
Yeah.
Okay.
I had to send it separately because the file size gets too big sometimes.
Gotcha.
So while Kyle cues that up for us.
Corals in general, what is a coral?
It's
I'll explain it to you. We got it.
You can just run it.
Pop it on. So we'll leave those on in the background. So when we're talking coral, so it's actually a living organism. A lot of people think it's like a plant or something.
Okay.
But what it is, it's made up of a whole bunch of individual things called polyps. And those individual things take in nutrients. They only have one hole, so it takes it in and poops out the rest through that same hole.
Ew.
And as it's doing all of that, it excretes calcium carbonate.
Okay.
And that's the substance that helps grow the dimensions of the reef.
Okay.
So that's sort of what it is. It's sort of like a living creature that makes this large underwater structure that ends up being really important for the ecosystems down there.
Right. Calcium carbonate's kind of like shell-like material, right?
Yeah, it's also what you would take if you were just to take a Tums.
Oh, really?
Yeah, calcium carbonate. Just like little rocks in your stomach, settle it down if you ate too much pizza.
Oh, my Lanta, Tom, you're so full of those facts, those little facts. So we've got the video up and running. Nice little video by NOAA there to sort of, give credence to why the coral reefs are important. As it's Coral Week, Tom, we'll actually speak very briefly about corals one more time before the episode's over. I'll make mention of it once more.
Sounds good.
And just one bit of advice from the NOAA website here is don't give corals as gifts, right? If you're out and about and you're scuba diving or you're on vacation,
peace off.
They look cool, but just leave them. Just don't take them, You destroy the ecosystem if you rip them up and want to keep them as a keepsake or give them to somebody else. So just leave them be.
Yep. Sounds good.
That's good. All right, next up, Scientific American put up a nice little video and have been talking about origami lattices. So again, we'll let you guys sort of peruse the video here. It's in GIF form, so it'll just play as we discuss. They're saying that origami lattices have twofold benefits for nanotechnology and medical care. So on the one end, nanotechnology, we're looking at things that are on the nanoscale or a billionth of a meter large.
We're talking about the small?
Yeah, really tiny.
We've talked about nanomaterials a little bit in previous episodes.
Mm-hmm.
So now we're combining nanomaterials with origami folding.
Yeah. Kind of bizarre, two things to put together. But this is becoming a little bit of a trend here in terms of research and in terms of topics that we've talked about on previous trèSci episodes, that origami sort of lends itself well to like a new way.
It's like these small scale nano space problems where you want to deliver this nanomaterial in there, but you can't really figure out how you can compact it in, and then once it gets there, how can you open it up to have it the way you want it to be.
Yeah.
So It's like sending in, if you wanted to send medication in to somebody using nanotechnology, you would want it to be encapsulating it to keep it safe.
Right.
But then maybe when it got there, you would want it to nicely just open up. And they're actually using the geometry of origami when making nanomaterials.
Yeah, it's pretty fascinating.
Crazy.
Yeah, I mean, who would have thought that, like, you know, just paper folding would have so much utility in newly developed scientific research?
Yeah, and we talked a little bit about some of the nanotechnology and folding, right? We talked about the ladybugs.
Yeah, so I don't know if that would be on the nanoscale, but that's...
Yeah, so but that's more of an example of folding. I think what I was trying to say,
exactly,
as opposed to the nanotechnology. So with the ladybug's wings, we didn't know how did it fold those up inside its wings and then get them to fly out and be strong enough, and we figured that out by looking at origami shapes.
Yeah, well, we didn't figure it out, but, but
Exactly.
somebody figured it out.
We read about it.
Yes, and there's also lots of utility in terms of future spacecraft that can unfold solar panels or, you know, solar sails, things of this nature. So yeah, just thought that was interesting that origami is really sort of I don't know, the new thing, the new hot thing, right? Like,
all cool. I remember about origami is one kid always knew how to fold the paper to make a frog, and then you would just flick the bottom and then the frog would hop along.
That's pretty tight.
Yeah,
that's pretty tight.
If you knew how to do that in 4th grade, you were pretty cool.
Yeah. I don't know how to fold anything. I can't even make a paper airplane, to be honest with you.
You weren't a troublemaker, huh? All right, moving on. The next one is coming to us from Nat Geo, and we're actually talking about glitter. Oddly enough, glitter gets used a lot in my house, actually.
Really?
For various arts and crafts, there's usually glitter all over the place.
Yeah, I mean,
but you know,
it's pretty
especially
ridiculous.
around Christmas time too.
Yes.
Tinsel and all that kind of stuff.
I mean, we got glitter balls on the tree right here.
So why are we talking about glitter? So it turns out that once you dispose of glitter and it goes down the drain, it turns into something called a microplastic, and those are kind of bad for the environment overall.
Yeah.
So what a microplastic is, the greatest volume of microplastics comes from 2 different places. Comes from trash that's broken down to really, really tiny bits by actually UV radiation, and then the waves pounding on them just turn the plastic into these really tiny microplastics. And then on the other hand, if you've ever seen like little beads in like face wash or things like toothpaste, those are another form of microplastics that they use for cosmetics.
Okay.
So glitter is just sort of another example of this sort of microplastic that might be bad for the environment. But when they looked at the research, they don't really see glitter being too big of an issue when they're looking for microplastics. But they're warning us that, you know, we're throwing a lot of microplastics into the ocean, which isn't a good idea.
Right.
So what else can we do besides glitter? Is there anything else we can use?
Well, Tom, there's a particular, I guess it would be, is it a mineral? No, it would be a...
Yeah, mica's a...
Okay.
Yeah,
a mineral called mica that comes in all different types of colors, and...
Yeah, it's really thin and reflective.
Yeah.
And it's sort of like nature's mineral glitter almost.
Yeah.
If you've ever seen a rock, or if you're walking through a parking lot, all the sunlight that's bouncing off and hurting your eyeballs, that's actually the little micrograins, and that's the really bright flashes on the concrete.
Yeah. So yeah.
I taught that to the 6th graders in camp.
Oh, really?
I don't think any of them knew what I was talking about, but there we go.
So look into mica glitter as a means to swap out traditional...
Yeah, so it's just a more natural way to get a glittery effect.
Cool. I like that. And last but not least, on the lightning rounds, just to tie it all together, this is also from Nat Geo. An image of a Pepsi can was found imprinted on a lobster's claw, reminding us yet again that the ocean is filled with trash.
That's a crazy image.
It is crazy.
It looks like it went out on the weekend, got a little drunk, got a tattoo it regretted. That's what it looks like.
Yep. Or yeah, it's like the stamp you get
like
when you go into the public house.
Yep.
Yeah. So this was a lobster caught off the coast of New Brunswick, Canada, It appeared to have a Pepsi product imprinted on its claw somehow. They're not sure if it's the can itself or if it's
like a logo from a piece of paper.
Yeah, who knows? Cardboard. Ironically enough, here's a quote from this Nat Geo article. This made us laugh. The lobster was hauled up by fisher Carissa Lindstrand, who told the CBC she recognized the brand because she reportedly drinks 12 cans of it daily. End quote. 12 cans of Pepsi
That's
daily.
how she recognized the brand.
That's how she knew.
I'm not really sure where that comes from.
A case of Pepsi every day.
I don't know. Yeah,
I don't know about that.
That's rough stuff.
Yeah, but anyways, just kind of goes hand in hand with the glitter story.
Eventually, it all ends up.
Yeah,
it ends up in the ocean most of the time. Yeah,
not good. Not good. Got to clean that ocean up. And that's the lightning round in a nutshell. So, Tom, we're going to talk a little bit in depth about a couple other stories.
Yeah, I think let's see how long we are after the first one, and then we'll see. We might have to save the next one for the next week.
Okay,
we'll see.
Yeah,
see how we're doing here.
That sounds fine.
So yeah, I hope you guys enjoyed the old lightning round. We're trying to bring to you more stories because we see a lot of cool stuff each week, and we kind of didn't really know how to go about it, but I think we got a good way to bring up more stories to you guys. So
yeah.
Hopefully you liked it. Give us some feedback. Let us know.
Yeah, absolutely. We can always trim the lightning round down a little bit for the next week.
A lot of good stories.
A lot of good stuff.
So what are we talking about a little more in depth?
So for the featured story this week, Tom, I want to get into talking a little bit about LED light bulbs.
Okay.
So
those are the new ones, the bright ones, right?
Yeah. Here's the thing. Not all light bulbs are created equal. And we have an image to bring up as well here with different types of lighting mechanism, light bulbs in particular. This image comes by way of ViriBright. So there's a few different...
Yeah, to me, when I think LED, I think of the swirly one.
That's actually...
I know, it's not.
Yeah,
exactly.
yeah.
But for whatever reason in my brain, I'm like, that's an LED light. I don't know.
I think of Christmas lights more often than anything else. But different bulbs the bulb has basically evolved as time has gone on. Yeah. So incandescent bulbs pass electricity through a resistive filament, which heats up and emits a glow. Compact fluorescent bulbs pass electricity through mercury vapor, which emits ultraviolet light, and then that gets absorbed by a phosphor coating inside of the bulb, which then glows or fluoresces. But LEDs, or light-emitting diode bulbs, pass electrons through a semiconductor to create light, and they do so in a more efficient manner than their incandescent and fluorescent counterparts. Thus, much of the world is turning to LED lighting as a more efficient, energy-efficient, cost-effective way to light just about everything up.
You get more bang for your buck.
You sure
do.
You
get a brighter light.
Yeah, you almost can't buy incandescent light bulbs in the hardware store anymore.
Yeah, most of them are LEDs.
They're there, but the showcase
section,
is the LED section.
I just recently bought a few LED lights, and we replaced some of our older lights that weren't, and the room seems like a different place. Everything's got a different color. It's more bright. Yeah, it's amazing what a different light bulb will do for you.
But Tom,
comes with a cost.
Huh? It does. In a recent study by Christopher Kyba and colleagues titled "Artificially Lit Surface of Earth at Night Increasing in Radiance and Extent," the consequences of a more ubiquitously LED-lit world take form. Using satellite radiometer data to calculate how the brightness of artificial light has changed, Kyba found that, quote, from 2012 to 2016, Earth's artificially lit outdoor area grew by 2.2% per year, with a total radiance growth of 1.8% per year. Continuously lit areas brightened at a rate of 2.2% per year, and large differences in national growth rates were observed, with lighting remaining stable or decreasing in only a few countries, end quote.
So overall, since LEDs have come about, the Earth is just getting brighter.
Exactly.
I mean, it kind of makes sense, but yeah, wow.
It kind of makes sense, but it's kind of counterintuitive, right? Because
these are supposed to be more energy efficient,
exactly,
better for everything.
They give more light off, so you shouldn't need more light bulbs, right? But
we're still using the same amount of light bulbs.
Because they're because they're cheaper, people just buy more of them. So they're sort of having the inverse effect as like what they intended when they developed these things.
Yeah, now they're just sort of used as like the new, better, brighter bulb.
Yeah.
That's pretty much it.
So the way the instrument on board the NOAA Suomi NPP satellite measures the light, it could also be misinterpreted a little bit here, as the sensor cannot detect light at wavelengths under 500 nanometers. This means that cities that are replacing more orange-emitting incandescent bulbs with white LEDs are actually just appearing to become dimmer, when in reality they are likely becoming brighter as well. So I have another image to bring up for you guys. So what does that mean exactly? So if you can imagine, let's say the town of Patchogue, right? The village of Patchogue had a ton of incandescent bulbs scattered in our light posts and, in the businesses and whatnot. This sensor on board the satellite that would have maybe measured this, let's say 5 years ago in 2012 or whatever it was, it would get sort of a brightness factor of, whatever it was. And as the bulbs then get replaced by LEDs, the wavelength changes. Right, so incandescent bulbs give off kind of a more orange, yellow,
like an
warmer
yellow,
hue to them. That's going to be in the visible wavelength region of around 600 to 650 nanometers, let's say. And as you replace that with LED bulbs, you're getting kind of more white light, and so any of that light that's under 500 nanometers, or the blue light here, that's not being accounted for on the sensor of that instrument, of the satellite. So they're understating the difference in brightness here because they can't measure that portion of the visible
LED lights.
Right. So it's probably even brighter than this 2.2% per year that they're saying. They just can't really account for all of that. Image credit goes to giangrandi.ch for that nice little...
So should we be worried about this brightening?
Well, so it's not really troublesome to too many people. I guess the thing that we should keep in mind here is how does it really affect ecosystems that might be surrounded in, closer to cities. And really, for my own personal endeavors, light pollution is really terrible for looking at the stars.
Yeah,
right?
That's a very true point.
Doing astronomy kind of stinks when it's bright out, so you always try to go to the darkest region you can find.
And it's getting brighter everywhere.
Yeah, if it's getting brighter everywhere, that means it's just getting harder to do astronomy from here on Earth, and that's kind of a bummer. So with this sort of misinterpretation kind of being thought about, to account for this, the researchers made comparisons to photographs from the International Space Station over a similar time frame. We have two more images, one of Calgary in 2010. So you can see
sort of how it changed.
Right, you can see how yellow and orange the city kind of looks here. And then contrast that with Calgary again in 2015, and you can see how the lighting has sort of, again, changed colors, and the brightness factor was then again measured by stacking these images on top of each other. So, an image credit goes to the ISS and Kyba et al. For that. So I want to leave us with one last quote by Dr. Kyba here. He says, "There is a potential for the solid-state lighting revolution to save energy and reduce light pollution, but only if we don't spend the savings on new light." End quote. So we can do it, right? But we just gotta, keep in mind that the light that we are replacing, we don't need as many, right? So let's spend our money elsewhere. We don't have to buy, it's like, oh, cool, I can get 2 light bulbs for the price of one old one. Just buy one and buy a cheeseburger or something. You know, like don't buy 2 light bulbs. I guess is the takeaway here.
Another thing we were talking about before too is I've been doing a lot of driving at night, doing Uber and stuff, and over time, a lot of the car's headlights just seem way brighter than they used to, and they have a more of a whitish tint to them, and they just seem to penetrate further distances. So it's just really bright on the road too.
Yeah,
because they use that sort of LED technology in the new headlights.
Yeah,
so it's brightness on all fronts.
That's true. Yeah, and it's the worst when it's kind of like there was like a light rain and like the road is, you know, super reflective and the light that
bouncing off of everywhere. Yeah.
Really hurts my eyes sometimes.
Yeah, some people have trouble driving at night for that very reason. They get headaches and things from all the lights.
Nancy Kalita in the chat says she loves looking at the stars. I am envious of her view of the stars now upstate.
Yeah, upstate New York's one of the best places to look at the stars.
For sure. Tom, what do you think? Should we?
Yeah, I say we save the other feature story for next week.
Okay.
And then let's talk about the poll results real quick.
You want?
So, if I'll just mention it and then you could follow it up. So we had a little poll. It's our first one.
Okay.
And it was on our Patreon page, right?
Yes.
And I think we're going to continue with polls like this on our Twitter and Facebook, and we're going to keep trying to do things like this.
Mm-hmm.
But so our first one was just which nebula do you like more?
Exactly. So what were our 2 options this week?
We had the Orion Nebula and the Crab Nebula.
Okay.
So what's a nebula real quick? Remind all the folks playing at home.
So a nebula, it's kind of...
I think I've heard it termed like a nursery for stars, right?
Sometimes. A nebula is like a weird thing to really put a definition on because it's kind of... It encompasses
a large collection of just gases and...
Yeah, it encompasses like a few different phenomena. But basically they called nebula something a nebula when it had more spread to it in the night sky than a single point of light, and they couldn't really tell what it was. Right?
Okay, so it's kind of like a general term.
Yeah, so planetary nebula come from when a star sort of sheds its outer layers and the gas gets exposed. But there are star kind of nurseries that we're talking about where there's new stars being formed. Sometimes those are called nebula. So nebula is kind of like...
Okay.
It's got a nebulous definition, right? Like it's not very well defined.
Got you.
So we put this poll out. Tom, do you want to announce the winners here?
The winner was surprisingly the Orion Nebula.
Actually. So yeah, Orion Nebula edged out the Crab Nebula in a 4-2 victory over on our Patreon page. Thank you to all of you guys who voted and took part in the poll. We're going to continue to do this every Friday, so that'll be cool.
And then hopefully we'll use some of the poll answers to gear our stories towards.
Exactly.
What are you looking for?
Do we want to put up, give us a little description here of what the Orion Nebula is?
Yeah, sure. Do we have the pictures up of the nebula?
Oh, we got it.
Yes,
up.
we do.
Oh, we do.
Winner. Let's go.
Winner, chicken dinner. So, also known as M42 in the Messier catalog, this region of space located about 1,500 light years away is a stellar nursery. It's where new stars are being born currently. In the night sky, it is located just below Orion's belt in the constellation of Orion the Hunter, and can even be faintly observed with the naked eye in areas with low light pollution.
Speaking of light pollution.
Speaking of the devil. The different colors of the nebula can be attributed to the different gases present: orange for hydrogen, green for oxygen, and red for sulfur, as well as infrared light in this particular image. And image credit goes to NASA, ESA, Robberto of the Space Telescope Science Institute and ESA, and the Hubble Space Telescope Orion Treasury Project team. A lot of people went into building this nice image.
Yeah, both of them, regardless of who won, are really impressive images.
Yeah.
In the chat, James says, "Rip crab." Karen says, "I still think the crab was more spectacular."
You gotta vote.
Yeah, you gotta vote.
You gotta vote.
Gotta get out there and vote.
Cool. And then should we end the show with this one little sort of
quick little send off?
Yeah. So we of course ask you guys to comment and tag us in anything on social media.
Yeah, Facebook, Twitter, Instagram,
Yep.
anything science, cloud pictures,
Whatever you're thinking
you see.
about, just let us know. Kayla Riley commented on a shared sciencenews.org article that we put up on our Facebook page talking about the alkali fly that we mentioned on last week's episode.
Yeah, that was the fly that like made the bubble for itself underwater.
Yep. She says, quote, "I know there are certain types of sunscreen that are better for the environment. Can you guys talk about those on the show so people can make smarter choices?" End quote. And that's in reference to the alkali fly sort of being in a precarious situation where its environment, its habitat might be threatened by people swimming in the lake that they found it in, Mono Lake, I think, in California. And sunscreen runoff from the tourists might make
Mess with that.
it hard to make that bubble that it survives with. So, our advice here, Tom, the culprit for sunscreen's marine pollution comes from oxybenzone, a substance that is good for broad spectrum UV protection, but has also been linked to coral bleaching and die-offs. And according to a 2015 study published by the Archives of Environmental Contamination and Toxicology, there is a direct link between the declining health of coral reefs and oxybenzone exposure from tourists. So, do your best to find oxybenzone-free sunscreen, especially if you'll be swimming somewhere other than a pool.
But if it's just in your backyard, kind of okay.
Yeah, it's okay. There is some other stuff that hasn't been totally scientifically researched as far as how oxybenzone might be bad for your health in a different way. So, maybe just look for the oxybenzone-free sunscreen anyway. But yeah, just to save the animals' habitats, the marine habitats, don't swim in the Great Barrier Reef with oxybenzone. And that's pretty much.
That'll do it for this week.
Yeah, that's an hour. Tom, thank you so much for joining me. This was a wonderful episode.
Yep, everybody, thanks for watching.
Yeah, thank you guys for being here. And of course, we'll see you next week with more science news.
Sounds good. Till then.